I want to talk a little bit, first of all, about the written section. I believe right now, unless I change the test, I haven't photocopied it yet. It'll be photocopied after this. Right now, I'm leaning towards 4 written questions, and I've told you it's going to be 4 of 5. So, Jake, you were away, but earlier today I did this, and I said the written section is going to have one angled projectile off of a cliff. Sorry, one horizontal projectile off of a cliff, one angled projectile off of a cliff, one vector question, either crossing a river or airplane with a crosswind, one projectile from the ground at an angle, and then one question where we run into a wall and I ask you to find the impact velocity like in review number 35. I'm going to pick 4 of those 5, I think. So let's try some of them right now. Okay. Horizontal off of a cliff. What can I ask? Well, let's draw a quick little picture here. Again, you can write this down or I can print this up for you after. But if I gave you a diagram and I said, I don't know, 73 meters per second, and then I need to give you something else. I either need to tell you the time of flight, but that makes it way easier because traditionally we spend most of our time finding time. Or I've got to give you one of the distances. I've either got to give you the height of the cliff or the range. And you know what? I think I've done the height of the cliff every single time. So just for giggles, just as a change, I'm going to say, suppose I gave you the range. Suppose I tell you that it travels, I don't know, 46 meters. And I say, find the height. Okay. The risk when I make questions up is because often I pick the same numbers. I might have just made up the exact same question on your test. I hope not. We'll find out. What would I do? Is there angles? So am I going to go components? No. Is it a projectile? Yeah. So what was my, so if it was, first of all, if there was angles, components was my first step no matter what. It's a projectile. Now what? There's something I should be doing right away as soon as it's a projectile. The T-chart. I'm going to fill in everything that I know, and I'm going to try and get this all next to it, so I'm going to go up here, I think. I'll show my work down below, but I would say horizontal, vertical, and right away, Matt, I can fill in these 2 here. I know that's 0. I know that's negative 9.8. This is good stuff. And almost always, you'll be able to fill in this. But this is going to vary from situation to situation. Here, what's Vx? 73. What's Vy initial? 0. Ryan, you may notice that I only have 2 pieces of information in each column. Not enough. There must be something else they told me. They're either going to tell you time of flight, in which case, because you'll have T in both columns, and now you can really go to town. Or they're going to give you the vertical distance. Make sure you make it negative and make it a displacement. We've done a bunch of those. Here, I think I gave you the horizontal. Yes? I think I told you dx was 46. And I'd like to find time. Now I'm committed horizontally. This is actually way nicer because have I got an equation that has d, vi, a, and t in it? I do. I think I have this. Oh. Do I need to write the plus a half at squared horizontally? Why not? Oh, a is 0, which also means no quadratic or square rooting, which is kind of nice. In fact, I think the time of flight is going to be 46 divided by 73. Wait a minute, Mr. Dueck, the question said find h. Yeah, but we're going to spend most of our time finding time. I get 0.63. I'll go 0.6301, but the nice thing here is this is going to be fairly accurate, I think. So far, so good? How's that help? Well, I guess I can now say this is 0.6301. Oh, and it also means that I can go here is 0.6301 seconds. What was this question asking me to find? Bree? The height. I don't have a formula with h in it. But what have I traditionally called that there height or a vertical distance? What symbol have I used for that traditionally so far this year? Did you say dy? If you did, say dy. If you didn't, fake it and say dy. Okay, so if I hear you correctly, you're saying, hey, Mr. Dueck, this now wants me to find that. And you'll notice now in the vertical column, I have 1, 2, 3 things. I can find the fourth. In fact, even better, there is an equation that has dy, distance, time, initial, and acceleration. And the d is already by itself. This is going to be straight plug and chug. I think dy is going to be vit plus a half ayt squared. I even think I can do this because vi is 0. It's going to be 0.5, negative 9.8, 0.6301 squared. 0.5 times negative 9.8 times that answer squared. And whoop. Why did I get it? Oh, because we're ending up below from where we started from, aren't we? I got the squared in there and everything, I think. It's, by the way, not a very high cliff, apparently, because it's moving pretty fast. Looks like negative 1 point. Now, if you said negative 1.95, I'd take that. But technically, height's a scalar. Technically, we don't say a mountain is negative 1.95 high. We say it's positive, but I'm not going to freak out if you leave a negative in your answer. And that negative didn't bother me. At first, Neve, I hesitated for a second, and then oh, no. I did end up below from where I started from. I should have been expecting a negative answer. Should have been. Okay? By the way, before I go further, so this was given a horizontal, find a vertical. What if we had been launched at an angle? The only difference would be your Vy would not be 0. The only difference would be the Vy initial wouldn't have canceled. You'd have something there when you typed in on your calculator. That'd be the only difference. Oh, and if you got a positive answer, you know you would have landed above from where you started from for some reason. I'm not going to throw one like that because I haven't given you one like that in your homework, but for what it's worth. If you get a negative answer, hey, I ended up on the ground below from where I started from. That's the height of my cliff. Is that all right? Yep.
If it's launched at an angle,
Yep.
if Vy is, like, imagine the 73 is the angle. Like,
Oh, the theta? The velocity? Yep. I need a theta, but yep.
What would be x be then?
73 cos theta. Cos. Right? We'd go components. So what? And remember, Vy was sine. If you had a good teacher, he would have come up with something dumb and stupid for you to remember that. He's got nothing. And Vx is cos, because sine and cos go together. Is that all right? Yeah. Okay. What else? Another thing I could ask for this is your impact velocity. Your impact velocity. So what? Good gosh, tight, Mr. Dueck. Magnitude and direction. huh? I would start out the same. I would say to myself, I need to find time. So I would still use Bree, that horizontal range, and I can find time of flight. I would still do a T-chart. I would still say,
Hey, Dueck. Horizontal, vertical, nothing.
was it 73? Is that what I said for my numbers?
Nothing.
And I would include the time of, what did I say the time of flight was? 0.6301? Is that what it was? You could find how fast it was traveling vertically when it hit. Because I think, Peter, the impact velocity, when it hits the ground, I think it's hitting the ground something like that. Could be steeper, could be shallower, but I'm telling you, it kind of looks like that. Ooh, is that at an angle? I would solve it with components. And here's the nice thing. One of these components, I already know, this one, because Vx never changes. Okay? And, oh, and if it was at an angle, it would have been the cos, whatever, but it would still be that number, whatever I got when I did the cos theta. It would never change for the rest of the question. Horizontally, I'd put it here. In this case, it's 73. The vertical is the one that's changing, that I've got to do some crunching. I want to find Vy at impact. In fact, I want to find Vy final. And I know T, A, and an, oh, I've got an equation that has V initial time A and V final. Not only that, the V final is already by itself. Oh, Mr. Dueck, you'd think the universe planned it that way. You never know. I could say, you know what? V final is going to be 0 plus negative 9.8 times 0.6301. V final is going to be, I guess I don't need to go 0 plus because that's not going to change anything. It's just going to be negative 9.8 times 0.6301. V final is negative 6.175. What's the negative telling me? Vertically, is it traveling up or down when it hits the ground? Down, which I knew, but that's a confirmation. By the way, if you did get a positive answer, which you might on the wall question, you could have hit the wall on your way up. That's all it would be telling you. It would be telling you, draw your velocity pointing upwards instead of drawing your velocity slanty pointing downwards. We'll look at one like that in a bit. So I think we can say this. Now, first, Peter, I need to point something out. What's the horizontal? How big in my diagram there? Can you see it? What's the vertical? How big? This is crappy scale. This should be really, really long horizontal and only about that long vertically. I've drawn a terrible, 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 terrible triangle. Like the theta is going to be almost 0. It's almost hitting the ground still vertically. It's barely had a chance to fall, which makes sense because what was the height of the cliff that we found? Like barely, not even 2 meters, right? So anyways, it's hitting the ground almost straight on. Just want you to be aware of that. The answer that I get is not going to look good with my diagram. But how could I find the resultant, which is the impact velocity, the combination of the two? You're not saying math 8 again, are you? Pythagoras? Yeah. And then I could use Pythag and SOHCH. Well, you know what? Which trig function is it going to be to find theta? Tangent. I'm not going to go further than that with this one. I will go further and actually crunch all the numbers for a different yuckier one. But that's about all I can do for you horizontally on a cliff. Horizontally on a cliff, I'm either going to ask you to find the height of the cliff if you know the range, or find the range if you know the height, or Find the impact velocity if you know one of the height or the range. And in all of those, your first strategy is going to be, I'm going to spend most of my time finding time. Yes, yes? Okay. What else can I ask? Cliff, at an angle. Sasha, are you actually crunching the numbers for this one? I see you typing like, are you actually crunching the numbers for this one? Sorry? Did you do the Pythagoras already too or not? What'd you get? I'll write down the answer so that kids can try at home. What'd you get? Which sounds about right because it's going to be, again, look up. It's really a triangle that looks like that where the hypotenuse is almost exactly the same length as the leg. That's what it would be to scale. So the fact that you barely got about 70 sounds right. Sorry, what'd you get? V equals 70? Point 0.3 to 3 sig figs, final answer, yes? And what'd you get for theta? It's going to be like 3 degrees or 4 degrees or something. 4.8? Really quickly, I'll double check, but I think those answers make sense to me. Just double checking really quickly. Yeah, 73.3, second function tan of 6.175 over 73, 4.8. Yep. I'll give you less dramatic numbers on your test so that you won't get such a bizarre triangle. Because that would terrify kids. They would say, wait a minute, my horizontal and my hypotenuse are the same to 2 sig figs. Yeah, it's because I made up numbers that were bad. I should have had it travel a lot further. Cliff at an angle. I may give this to you as a word problem or as a picture, but I'm just going to give it to you now as a picture. I'm going to say, hey, we got a cliff. Launching at an angle. Yoink. 51 meters per second. $29 degrees. $83 meters. Find the range. I have to laugh every time I look back there because you look totally headless. I'm sorry, it's just perfect. I can't see your body at all, and all I see is a head sitting on top of the table with your chin right there. Go ahead, I don't care, it was very Halloween appropriate somehow. Or the rumors about Mr. Dueck's teaching are true, and he's finally snapped. Yeah, that could be too. Talk me through this. There's something you should be going, I'm going to do right away. Components. There's angles, components. That to me is a first instant step. Oh, and then T-table. So let's do the components. I think Vx is going to be the velocity cos 29, and Vy is going to be the velocity sine 29. And I think I said it, but I'll say it again. That shortcut only works if you're firing something upwards, but that's what I'm going to give you this year. If you're firing something downwards or at weird, if it looks weird, carefully do the trig, please. But for now, we got a good shortcut.
You're never giving us one where you launch it down?
Not on a test. I think there is one next unit in the big review package, and it's a stunt car, and it's a nerdly cool question, or it's a stunt rocket. Anyways, it's cool, so I left it. But I don't think I'm going to be giving you actually one like that on your test.
Okay.
Again, the homework should be tougher than the quizzes, which should be tougher than the test, ideally. If I play my cards right, that'll happen most of the time, with the odd exception. I will always put, almost always put, one curveball on the multiple choice. I don't think there is one on this first one, though. I know there is one on Unit 2, definitely on Unit 3. There's a nasty that a lot of kids get wrong, but that's, again, good stretching for your brain. 51 cos. 44.6. 51 sine. 24.725. I guess I'll go 24.7. But I'll carry that extra one on my calculator. A few digits. Oh, yeah. T-table, Dueck. Gotcha. Horizontal, vertical, big letter T. AX, nothing. AY, something. VX, 44.6. VY initial, 24.7. By the way, I think you know this, but I'll ask again. How come I always put an initial on the VY, but I don't bother on the VX? Hang on a second. We're back. Why do I put initial on the Y, but not on the X?
Because the x is constant.
X is constant, and it's such a little thing, but I want to remind myself of that. And you're going to find one of the strategies when I teach you is any little easy trick that I can do to keep from tripping on my own brain. If it takes less than 1 second, I'm in. If it takes more, I'm lazy. This is not enough. I only have 2 things in each column. Oh, what haven't I used yet? And I got to be fussy. It's not a distance, it's a displacement. Most common mistake is that right there. Why is that wrong? I'm ending up below from where I started from. Okay? Now, here's the problem. Horizontally off of a cliff, if you miss that negative, you'll get an error on your calculator and you'll catch it. At an angle, because of that quadratic equation, often you'll get an answer that'll work and you won't catch it. So, remember that, please. I want to find time. This is going to be the quadratic formula. Or find Vy using the squared equation. Who wants to do quadratic formula? Who wants to do find Vy using the squared equation? So I guess the 4 people who voted for that outweigh the 1 person who voted, and the rest of you are just wallflowers. Okay? So we're going to go like this. We're going to find that over here. We can use, I got to scroll up just a tiny bit. I have acceleration, initial, displacement, and final. I can use this. Right? Right. Oh, I got the V final by itself. Oh, except I got a V final squared. How to get rid of a squared? Square root. In the interest of time, I'm going to go chunk. Chunk. I'm going to go 24.7 squared. That's a terrible 7. Come on. There we go. Plus 2, negative 9.8, negative 83. Oh, I got this number on my calculator. Squared plus 2 times negative 9.8 times negative 83. Double checked. I typed that in right. Yep. What the? Oh, square root, Mr. Dueck. Square root. 47.31. 47.31. 47.31. 47.31. Why is that wrong? Because it is. I have to, this is a scalar equation, unfortunately. I have to clue in when it hits the ground, it's traveling downwards. I have to add that in myself. But if I do that, now finding time is pretty mundane. Time is going to be V final minus V initial over A. It's going to be negative 47.31. Take away 24.7 divided by negative 9.8. Negative 4, whoop, try that again. Negative, oh, you know what? I'm going to use my answer button because that's stored on my calculator. Minus 24.7 divided by negative 9.8. 7.3. Those of you who use the quadratic formula, hopefully you got the same thing. I get a time of flight of, I'll go 7.348. It's not what they asked me to find. It said find the range. Do you see it, Matt? Now I can actually add time in this column here. Now I do have three things. I can find the fourth. In fact, I think, Matt, the range is going to end up being, call me silly, dx equals vxt. Dx equals Vx was 44.6 times 70.348 times 44.6, and I get a range of 328 meters. Sasha, is this my final answer? Say yes. How many sig figs am I going to do in my final answer? 2 or 3? Oh, geez, that's terrible. That's still terrible. All right. Insert, no, draw, little box. Ah, there we go. Huh? Eh? There you go. Pause for a second. So that's at a cliff. And again, cliff at an angle, okay, I'm either going to give you the range, find the height. You know what? I'm not going to do that, because if I give you the range and say find the height, you may have noticed that the quadratic cancels. You can get away without the quadratic. And I do want there to be one, or you have to deal with a quadratic equation, either use the quadratic formula or find Vy final, add the negative, because you know it's going down, and work your way around it. What else did I say? From ground at an angle to ground at an angle, I'm going to leave that until the end if you want me to go over it. But what I want to talk about is hitting the wall, metaphorically, not really, and then I'll try and do a river or airplane question. Click. Hitting a wall. What do we mean by that? Something like this. Yoink. Yoink. I have to make sure this actually hits the wall, so let me just do, I'm doing some really quick. I'm making up numbers. Oh, hang on. I have one here that worked. I can just slightly change the numbers for. Let's make this angle 32 degrees. Let's make it 41 meters per second. And supposing I told you that this distance here was 43 meters, and I told you that it's hitting the wall. Find impact velocity, magnitude, and direction. Now, I've just made up a question. I'm not sure if when it hits the wall, it's still on its way up or whether it's on its way down, which is why I didn't extend my dotted line. I'll find out when I find the impact vertical component. Because if the impact vertical component is positive, oh, it's still on its way up. If it's negative, which I think it is because I was doing some quick number crunching in my head, I hope it is, then it's on its way down. So far, so good? Do you see an angle? Well, I'm going to go components. First thing, I would say, hey, Vx is going to be 41 cos 32. Vy initial is going to be 41 sine 32. Cos 32. 34.77. Sine 32. 21.73. And give me 2 seconds here. Dx equals Vxt divided by t. 43 divided by 34.77 equals that. Vi 21.73 plus negative 9.8 times that equals. Okay. I'm gonna change my oh, come on, eraser. There we go. I'm gonna change my diagram slightly. I've just done some quick math. It's still on its way up. I'm pretty sure when it hits, it's still on its way up. So what's the impact velocity going to look like? Well, I'm pretty sure it's going to look kind of like that. It's leveling out, but it's still on its way up. I hope. I just did some really quick math, and I'll feel really foolish if it does end up being on its way down. Neve, do you notice that that velocity that I just drew, this V impact, is at an angle? Are you suggesting I should probably solve it using components? You would be correct, madam. I would say, hey, that's Vx, that's Vy. Where Vx is 34.77, is Vy going to be 21.73? No. By the way, that's by far the most common mistake I see kids make. They don't know which Vy to look for, so they take Vy initial, they put it there, and then when they do the Pythagoras, you know what they get? They get exactly 41 meters per second, and when they solve for theta, they get 32 degrees. They've just uncomponentized their original velocity, and they just found their original angled velocity, and they go, well, that looks really familiar. That's not Vy. This is really going to be Vy final at impact. Neve, did you say we were at an angle? And so we went components? Is this a projectile? Then where's my t-table? That's my next. Yes? I'm going to say to myself, horizontal, vertical, nothing, negative 9.8. 34.77, Vy initial, 21.73. I'd like to find Vy final, except how many things do I have in the vertical column? Only 2. I can't use 2 to find 3. I need 3 to find 4. Well, what haven't I used yet that the diagram gave me? What is that 43? Horizontal or vertical and what? So if I hear you correctly, I can go And now I have three things. I can spend my time finding time. But it's going to be horizontal. Ooh, which actually is nicer because this is not going to be a yucky quadratic. I could give you the vertical. I could tell you how high up the wall it hit, in which case that would be a positive displacement in the vertical, and it would be a quadratic equation. Not gonna. Too much work. I'm only going to give you one cliff angle quadratic on your test. One is enough. So I'll give you a horizontal if you have this question. Why is that so nice? Because it seems to me that... Was that too fast? I did dx equals vxt, and then I said divide by vx. I'm running out of time because some of you told me you have to go at 4 o'clock, so I'm cutting corners here. Yeah, the Math 12 tutorial that I did didn't help, but he was a good student, so. Is that okay, Jake? Yeah. So the time of flight is going to end up being 43 divided by 34.77. The time of flight is going to end up being 43 divided by 34.77. Time of flight looks like it hits the wall 1.23669. I'm going to go 1.237 seconds after launch. 1.237 seconds after launch. Oh, which means time over here is 1.237 seconds after launch. Why is that so nice? How many things do I now have in my vertical column, Tanisha?
Say 3.
And so I can find a fourth. Do I have an equation that has Vy final V in it? Yeah! I can use good old... Right? This time, V initial isn't 0. It was in the horizontal one that we did a while ago. 21.73 plus negative 9.8 times 1.237. Oh, I hope I get a positive answer because I told you it was still on the way up. Let's find out. 21.73 plus negative 9.8 times answer. Please give me positive. Oh. It looks like when we hit the wall, we're traveling upwards at 9.61 meters per second. We're traveling upwards at 9.61 meters per second. That's my impact velocity components. Now, Ryan, can you tell me how I can find the magnitude of the impact velocity if I know that and that? You're not saying math 8 Pythagoras again, are you? Yes. And then it would be tangent. Oh, looked in the bulb. That was dumb. Wow. It would be tangent, and this would be above the horizontal instead of below the horizontal. Are you okay taking the rest of it the rest of the way yourself? So I'm just going to write here, use Pyth tan above the horizontal. For those of you who really want to know, it's going to be that squared plus 34.77 squared, square root. It's going to be 36.1 meters per second at second function tangent 9.61 divided by 34.77. 15.5 degrees above the horizontal, if you want to try yourself, okay? Since you folks are here, there's about a 90% chance you'll see something like this, okay? It'll either be on its way up when it hits the wall or on its way down. How can I tell if it's on its way down? What will Vy final be? Negative. Negative. I'll give you an accurate picture if I do draw a picture. I got 7 minutes. Bree and Neve, you guys are good? Airplane. airplane. An airplane wants to travel with a ground velocity of, let's make up a number, 285 meters per second due north. If the wind is blowing towards the west at
35 meters.
no, too short. I want to get a better triangle. I'm going to go 98 meters per second. How fast and what direction should the engine velocity be? Question mark. An airplane wants to travel with a ground velocity of that due north. There's a crosswind of blowing towards the west at 98 meters per second. How fast and in what direction should the engine velocity be? This, to me, is actually a much more useful question, because most of the time, if you're a pilot, you know what direction you want to head, and you would like to figure out which way do I point my plane to cancel out the wind. Okay? The equation that we're going to use, the approach that we're going to use is as follows. We're going to say, good gosh, engine velocity, wind velocity results in ground velocity. What's this question asking me to find? The engine velocity. See the vector equation? Is the engine velocity by itself? What else is on that side, Bree? How would I move that there wind over to the other side of the equation? What's right in front of it? Do you see a plus sign right in front of it? So how would I move it over? Subtract. We're going to subtract vectors. How do we subtract vectors? Oh, we don't. Let's write this down, though. So I think the engine velocity is going to be the ground velocity, take away the wind, and I heard Jordan say, hey, Dueck, you're going to add the opposite. So I changed the minus to a plus and put a negative in front of there. Oh, I also see north, south, east, and west. I have to do this because the number of times I've botched that would amaze you. Can you see the two vectors I'm going to add together? Are you ready? Bree, you did so good. Let's keep going. The first vector, I think, is this one, is v ground. What's v ground? Magnitude and direction from the question, please. It would look like this. Right? Plus, then I see negative v wind. First of all, what's v wind? Ignore the negative. What's wind velocity, magnitude, and direction? What would negative that be? 98 meters per second? And the most common mistake is kids draw this triangle wrong. They point the wind to the west. They're going to get the right magnitude but the wrong theta. Oh, and the second most common mistake is they draw the wind almost as long as the 285. I think that's a better scale, yeah? Roughly 1/3 as long, roughly. In other words, this triangle is going to go 285, 98. You know which way I want to point the plane, Tanisha? That way, into the wind, which makes sense now. That makes sense. This is going to be engine and theta. And again, Neve, you can see a lot of kids, they'll just read the question in haste, and they'll say, oh, I see two vectors. Dueck says add them tip to tail. And they're going to go this plus that, and you can see you get a totally different vector. That's the most common mistake. Ryan, this wouldn't be Pythagoras again, would it? Oh, you're kidding me! Mr. Dueck, we should almost be paying money to do math this fun. Absolutely. So the engine velocity, I'm just going to do the Pythagoras really, really quick. The magnitude is going to be 285 squared plus 98 squared, square root 301. At, always from where the resultant is starting. So don't put the theta up in the right corner. By the way, that theta there, south of north, east of west, what of what? East of north. Yeah, if you got a wind blowing from the west and you want to go north, you better point your plane east of north. East to cancel out the wind, north because that's which way you want to go. So east of north. And the theta is going to be, once again, tangent. I 19.0 degrees. Okay. So I've done horizontally off of a cliff, check. Angle off of a cliff, check. Oh, and horizontally I said it's either going to be find the range, find the height, or find the impact velocity. Off of a cliff, it's going to be almost certainly I'm going to give you the height, find the range, because that forces you to use the quadratic equation. I've done hitting the wall. We've all hit the wall, so to speak. And I just did river or airplane question. There was the fifth one was off the ground at an angle. I can do that, but yeah. How come I put the plus in there? Okay, great question. Neve, can you read to me what this says here? VE plus negative. Which way is the wind pointing in the original question? West. Which way did I point it? East. So that's the negative. That's that plus sign. Plus the negative. In other words, what we said for subtracting vectors, there is a rule. I said don't learn a rule for subtracting vectors. You can turn it into an addition. How? Add the opposite.
So this is going to be done when you're doing about line or
This is going to be, sorry?
like the river line or
All I'm saying is in this case, because for the airplane, we start off with this velocity equation here. If I ask you to find one of those, you'll probably have to subtract to get it by itself, in which case, we're subtracting vectors. It's about the only time this year, sorry, that's a fib. It's almost the only time this year that we'll be subtracting vectors. Is that okay? Any others or questions from the review or something you're wondering about? Otherwise, we can wrap it up, but I'm still willing to stick around because I have no life. And I'm entertained by Sasha's pen tricks. Any other questions from the review, from the homework, conceptual? I haven't done from the ground at an angle, but I think we did that in the notes in Physics 11. If you can handle cliff at an angle and cliff horizontally, ground at an angle, is just make your cliff height 0, and it kind of falls apart from there. Except you know more stuff. You know your final velocity is the same as the initial velocity. Going once. Any more? Okay, let me just pause the video. Right click.